In the diagram below, what number could represent B? And if you notice, we have B right down here inside of integers, and integers, of course, is held within rational numbers. So we have to think about integers. Integers are those numbers that are on that perfect number line. Some of these we're going to have to put in the calculator just to make sure. So we're going to start with 2/5. 2 divided by 5. Oh, that's a decimal. We have no decimals on an integer number line. Let's look at B. We've got -11 divided by 5. Again, a decimal. That's not going to work for us. And C, we've got 7 divided by 3, which is a repeating decimal. Not going to work. So let's try -9 divided by 3, and that gives us -3, which would absolutely be on a perfect integer number line. So let's look at the next one. It says, which list contains only integers? So you have to be real careful in that we're looking for only integers. Can't have anything else. So let's start with A. Okay, so we're going to start by putting 27 divided by 9. 3 is definitely an integer, so we're going to go ahead and put a check there. And then we're going to go on to our next line. Oops, come to the calculator. And we're going to do the square root of 4, which is 2. That is also definitely an integer. Let me fix my pen because I messed it up. All right, we should have that now. And -4 is definitely an integer. So it looks like we may have found our answer already, but let's go ahead and check everything else. 6.0 is an integer. It would be on a perfect number line. But let's come over here and look at the square root of 5. So let's put that in our calculator, and we get a definite irrational number, so that goes away. So let's look over here at B, and B says negative square root of 81, so let's go ahead and put that in our calculator. Negative square root of 81, that is -9, that's definitely an integer. -7 is an integer, but then we have 4/5. So let's see what happens when we take 4 divided by 5. That is a decimal that stops, it's rational, but it is definitely not on our perfect number line. So let's go over here and clear one more time. Let's try 4/3. 4 divided by 3. That's a decimal that repeats. Again, rational, but definitely not an integer, so A is your answer. Always check all your choices, though, just to stop yourself from making mistakes. This one says, which set of numbers does not contain a natural number? So natural numbers are the lady that counted the hairs on her legs, 1, 2, 3, so on and so forth. So can you have -10 hairs on your legs? Nope. So that one satisfies it. Can you have 2/3 of a hair on your leg? Nope. Can't do that either. Can you have 1 hair on your leg? Yes, you can. So that is a natural number. So that cuts this one out because we're looking for the one that does not have natural numbers. So let's go to the next one, B. Can you have -8 hairs on your legs? You cannot. So that one works. Can you have 0 hairs on your leg? Absolutely not. I'm sorry. Doesn't matter how smooth your legs are, you have hair. So that one's out too. I'm looking at Miss Benson and she's looking at me like I'm crazy. So, can you have -6 hairs? No, you cannot. So that one works because we're looking for not. Can you have -2/5 hairs? No, you can't. So that's not natural. Can you have 1.7 hairs? No, you cannot. So that's not natural. Can you have 3 hairs? Yes, you can. So that is natural, so that goes away. I sure hope this last one's an answer, otherwise I did something wrong. Okay, -12. Can you have -12 hairs on your legs? Nope. So that one works. Can you have 0 hairs? We had this discussion. Nope. Cannot have 0. Can you have 0.5 hairs? Nope, you cannot. And finally, we have the square root of 2. Uh-oh, I think we have the square root of 2. Well, let me fix that. I had 22. 1 point. Can you have 1.4, 1, 4, 2, 1, 3, 5, 6, and so on hairs? Absolutely not. So that has got to be our answer. That one was kind of tricky. You had to think about it. Okay? So let's go ahead and go to our next slide. Oh boy, I went twice. Let's go back. Identify each number that is not a rational number. So we're going to have to go through and put a lot of numbers in the calculator. We're going to start with the square root of 16. That gives us 4. That is definitely a rational number. Because if you're looking for things that are not rational, you're looking for irrational. So let's try the square root of 7. Oh boy, that goes on forever. That is definitely irrational. Now let's try the square root of 15. Again, it goes on forever. No pattern, no stopping. So that is irrational. Now let's try the square root of 6. Goes on forever. There's another irrational one. So now let's try the square root of 11. Oh boy, that goes forever. That is definitely irrational. Now let's try the square root of 5. Always use your calculator, so important. That one goes on forever, no pattern, so that is definitely irrational. Now let's try the square root of 9. 3. Definitely rational. And the last one, never skip anything. Put them all in your calculator. Square root of 1 is definitely 1, so that is rational. So that means the ones that are not rational are square root of 7, square root of 15, square root of 6, square root of 11, and the square root of 5. All of those are square roots, and they are non-perfect squares. That's what makes them irrational. All right, let's try our next one. Okay, identify all the sets of numbers that contain negative 18 over 3. First thing I'm going to do is put that in my calculator. Negative 18 divided by 3. That gives us negative 6. So I have to identify every group that contains negative 6. Let's look at natural. Can you have negative 6 hairs? You cannot, so let's mark it out. After natural comes whole. Whole starts at 0 and keeps counting, so that does not have negative 6 in it either. Integer. Negative 6 definitely is on a perfect number line, so it is an integer. Rational. Absolutely it is rational because as you know, integer, whole, and natural numbers are all rational. Irrational, absolutely not. Negative 6, even if it was negative 6.0, does not have a decimal that goes on forever and ever and ever with no pattern. And yes, they are definitely real, no doubt about that. So it is part of the real, rational, and integer number sets. All right. Let's see what we have on our next one. Oh, that's where Ms. Benson wants me to stop. Let's go on to our next video.